took a physiology and histology exam. So we don't have any of that to go over today. Well, that's not exactly true, because of course the day after the exam we have a quiz. So I guess I could study for that. But we're also going to talk about anatomy. A little bit of radiology. So this one's going to be kind of brief because the pictures are more help than my words are going to be, but there's many ways you can take radiographs, obviously, and we're talking about the abdomen specific. There's right lateral, ventrodorsal, dorsoventral, and gas in the GI tract gives a natural contrast because of those gradients, those radiograph gradients. For example, air shows up differently than metal does on a radiograph because the x-rays go through the air, but they don't go through the metal, they bounce off the metal. And so you can use, there's something called a barium study, which is where some liquid barium, I don't know if it's pure barium or what, but they'll put that in the gastrointestinal tract and it'll show up very well on the radiograph because metal is reflective for radiographs. The diaphragm, it's very visible on a radiograph. It's only really possible to see the thoracic surface. You don't want to see gas in the abdomen because that's bad news. That means there's probably a hole somewhere. Yeah, not a good sign. Any other external structures are easy to see, like mammary glands, aka nipples, right, on the dog or your cat. Easy to see the prepuce, the urinary bladder, but it takes some getting used to. Radiology has been referred to in the past as imaginology because you kind of have to get used to what you're seeing because there's very slight differences sometimes. Okay, and then it's easy to see bones in a radiograph, right? I mean, that's one of the most prominent features. But whenever you get a radiograph as a veterinarian or as any kind of doctor, you want to evaluate anything in the film. Don't just cherry pick what you're wanting to see. You need to look at every structure in the radiograph, make sure everything's right, because you could pick up on a secondary problem or the cause of your primary issue. The liver is also it can be easy to see, but also can be difficult to see depending on which view you take. You can get border effacement if you have because the stomach's nearby, and the stomach is also soft tissue, so it can kind of coalesce and look like the same structure when it's not. It looks a little different. Dog versus cat, for example. In the dog, the left lateral lobe of the liver is what you would normally see in a abdominal radiograph, but in the cat, the right lateral lobe is going to be more visible. And then if you've got hepatomegaly, which is enlargement of the liver, or if you've got microhepatica, which is shrinking of the liver, it's also possible to see that in a radiograph. Okay, and then the spleen, it's another not benchmark, check mark you can find on a radiograph. It's pretty easy to see once you know where it is, but I mean, I can't show you these resources, unfortunately. Not yet. Because these ones are copyrighted. But anyway, kidneys. We have a left one and a right one, obviously, and these are found in the cranial dorsal abdomen. Hey, butterfly girl. The left kidney is going to be more caudal, which means more toward the tail in dogs and cats, and so it's easy to tell which one's which on a radiograph, because the left, I mean, it's easy to remember. You can say left kidney was left behind, right? You don't really need to know this. Hey, Cristiano. You don't really need to know this, but in cats, the kidneys are located in between L1 and L5, and in dogs, they can be located between 3. So they're a little bit moved to dogs, at least in relation to vertebrae. Hold on. Having some internet connectivity issues. Okay, we're back. How old am I? I'm 21. Cats have more rounded kidneys, whereas dogs have more kidney bean shaped kidneys. And usually the left kidney is more mobile or pendulous, it seems. Okay. That's cool. In the urinary bladder, moving on to the bladder, we have the apex, the body, and the neck. The apex is kind of the bottom, and the neck is the top, and the body's the middle, I think. It's somewhat difficult to evaluate it on a ventrodorsal view because the spine and the colon are in the way. But this is one of those structures you gotta kind of work to look for, because there's a lot of fat in the visceral region sometimes not so much. But it is a soft tissue, and it's hollow, but it's a soft tissue mass, kind of. It's not a tumor, obviously. It's the bladder, but it's not like it's made of metal, you know. It's not going to show up extremely visibly. And we're losing internet again. Just give this a second here. My internet seems to shut off for no reason all the time. Don't know why. It's kind of annoying, but whatever. It's not working yet. Sure is cold in here though. We opened the windows overnight, my brother and I, and cheaper than air conditioning, but boy, it gets cold. It was like 62 degrees in our apartment. Still is, I think. Well, maybe. Okay, finally reconnected. I don't know. It seems to be struggling. How's my vertical stream? Are you guys able to? How's it going? Is it slow? Is it disconnecting? Because my horizontal stream is definitely disconnecting. Whatever, I'm just talking about vet school stuff. Let's keep moving. So the stomach has 4 regions: the cardia, the fundus, the body, and the pylorus. And they're a little different in the cat versus the dog. In a right lateral radiograph, the gas is going to go to the left side of the stomach, and the fundus is on the left side of the stomach. So we can tell in a right lateral radiograph that all the gas is in the fundus, right? The size of the stomach varies widely. I mean, it's very pliable. You can eat a bunch of food. It can fill with a bunch of gas or fluid. That's just normal physiology. It's meant to do that. It's meant to stretch. But if it's filled with a lot of gas, it's very visible on a radiograph because, again, air is like black on a radiograph, while metal is completely white. And so in between you have bone, organs, soft tissue, water, fat. Anyway, and so if you can tell, it's a left lateral because all the gas will be in the pylorus instead of the fundus. And there's other tests you can do, again, barium studies. And that's especially if you want to see all the small intestinal twists and turns and stuff. You can use barium. And then the dog has a cecum. It's like a corkscrew kind of C-shaped thing. It's on the right side of the abdomen, about right middle. But it's not really visible in the cat. Kind of like ours are, we don't really have much of a cecum. nor do cats. A colon, there's the ascending, transverse, and then descending colon. Yep. All right. The cecum can fill with gas too, so it's helpful. Once you view, I mean, you just know that it's the cecum because there's a distinct shape. It's just a little bit of gas. But again, whenever there's gas or air or whatever, then it's black on the radiograph. It's a spot of darkness that you can see. Again, cats don't have that. The colon is about as wide as L7 is long, which means the lumbar vertebrae 7. So if it's any wider than that, then there might be an obstruction. If it's any thinner, then it's probably not too big of a deal. I don't even think it gets thinner. I think it just exists at that width. But anyway, moving on. In about 25 to 30 days, well, looks like in cats 35 to 39 days, and in dogs 42 to 45 days, you are able to see, if the animal's pregnant, you're able to see their babies in their uterus through a radiograph. Like you can see all the bones and stuff. It's very, very interesting. A normal, moving on to the prostate, a normal prostate may or may not be visualized in a normal dog, and it's never really seen in a cat, in male cats. I mean, it's never seen in female anything, because they don't have one. But, yeah, because cats, theirs just tiny. It's like the size of a pea. But in dogs, it's a little bigger, especially in intact males, meaning they still have their reproductive organs. I'll just say that. But it can be enlarged, which is unusual, or I don't know how unusual it is, but it's not right. It's called prostatomegaly, and it can occlude the bladder, which makes it hard for the animal to pee. Humans experience the same thing. But that can occur. There's other, it's easy to see the liver, the spleen, the stomach, the small intestine, the colon, right and left kidney, bladder, male reproductive landmarks like the prepuce, and then the body wall of the animal. It's easy to see those in a radiograph, but it's not necessarily easy to see the gallbladder or the adrenal glands or the pancreas or the uterus or the prostate or the lymph nodes. It's only possible really to see the prostate if, again, it's enlarged, and that isn't normal physiology. Okay, that's all for that is all for anatomy. Moving on to epidemiology. We have what we did yesterday was we talked a little bit more about confounding, but then we talked about study designs. Okay. There's many studies obviously, in the world, but not all studies are equal. Not all studies are good. Not all studies are high quality evidence, or not all studies contain high quality evidence. So there's experimental studies, which are usually random assignment or whatever. These can consist of laboratory experiments, they can consist of clinical trials, field experiments, but those are actually 3 tiers as well. Lab experiments are the most controlled and the most probably the least unreliable, right? They're the most reliable ways to get evidence, I would say, because you've got most control over your controls and your constants and all the parts of a experiment, right? But then there's clinical trials, which are more reasonable, right? Because not everyone has access to a lab. They are probably less expensive, but they don't offer as much control of the environment or the challenge presented. They're not as reliable, or the evidence is not as reliable. It's very hard, very difficult to control the environment and the challenge in this type of experiment. But, I mean, it's still a study. It's just a different kind. Then there's observational studies. These can consist of observations done prospectively, which, you prepare and standardize the study. Observations done in retrospect, which is like after the fact. And then observations done at the population level. You just take a chunk of the population and say, what's going on here? But in this, you're not directly manipulating the investigation like you were in the experimental studies. So when you go from epidemiologic to experimental, epidemiologic, clinical, experimental, you have less control, and over here you have more control. Then there's a difference between observation and intervention. So an interventional trial, that's where you, again, control variables. Observational, you don't control anything, you just observe. But interventional, you intervene. Right? Kind of makes sense. That's where you're assigning the variables. You are determining, you're manipulating the experiment. Then there's validity of an experiment. For example, internal validity versus external validity. For an experiment to be valid internally, basically you just have to have a well-designed study. And a lot of studies are well-designed nowadays, so that doesn't really mean much. But for it to be externally valid, it must first have internal validity, so it needs to be a well-designed experiment. But it also needs to be applicable to the target population. So basically, if you want to know if a study is internally valid, you got to ask, was the study well made? If you want to know if it's externally valid, you got to ask, does it apply to me or to X population? Next, we have interventional trials versus observational studies. Interventional trials are usually internally valid, while observational studies are usually externally valid if they're internally valid. And then we're going to talk about causation versus correlation. Many people have heard that correlation does not assume causation, or correlation does not inherently mean that there is causation present, because no study can prove anything. First of all, it's good to know that. Now, studies can suggest something, but you can't just say, oh, it's been proven that this happened, because no study's perfect. How do you know that it's been proven? You could have a study the next day that proves that study was phony. So interventional trials usually provide strong evidence for causation, and observational studies can usually only establish correlation. Doesn't necessarily mean that's all they do, though. They can do both. Then there's the Bradford Hill criteria. These are key points to know if you're trying to demonstrate correlation: the strength of evidence, the consistency or the replication of evidence, the temporality of evidence, the time, like the time frame, the biological gradient or the dose response of the evidence, the biological plausibility, does it make sense with what you know physiologically, the experimental, is it able to be reproduced experimentally, that evidence, and the specificity of that evidence. For example, a single exposure should produce one outcome, not multiple, and it should only be one exposure, ideally. Also, there's the elimination aspect. If you get rid of a toxin, that should eliminate X disease or whatever. These are some important things to know. Major applications of interventional trials and observational studies. Interventional trials can usually support or dispute hypotheses, and they can establish cause and effect. Meanwhile, observational studies are used to investigate outbreaks, assess risk, generate hypotheses in the first place, and if there's relationships between two variables, it can identify those relationships. But that's it for epidemiology. Now, I want to try and go over this quiz real quick. This is a physiology and histology quiz study guide that I got AI to make. I'm going to see if I can. Oh, it looks like my stream's working now. Okay. So on my horizontal stream, I've got it can see all the questions here. Question 1. Which division of the nervous system serves as the major integrative and organizational center, and what structures anatomically compose it? The answer is C. I just scrolled to it, but the integrative and organizational center is the CNS, central nervous system, which is the brain and the spinal cord. The peripheral nervous system is part of it, but it's not the center of it. Question 2, if a neural signal is described as efferent and somatic, what does this imply about the signal's direction and target organs? So, I don't think it's A, because it literally says it's afferent, and that's not what efferent is. B, no. Okay, this one's kind of easy because it literally gives you the answer. So efferent means it's exiting the CNS. Think efferent, and then E for exit. And then somatic means it's not visceral, which means not targeting organs. It's just targeting muscles and such. So, yep, the answer is D. Question 3, what term is used to describe an accumulation of cell bodies of similar function within the CNS? It should be a ganglion. No, it's a nucleus. I got that wrong, even though I saw it. Accumulation of cell bodies of similar function. A ganglion is a cluster of neurons. Okay, good to know. Question 4. Which component is the primary constituent of white matter within the CNS and spinal cord? A, neuronal cell bodies. B, neuronal axons. C, astrocytes and microglia. D, dendrites and synapses. I think it's either A or C. Oh, it was B. Okay, I was wrong both ways. White matter is mainly composed of neuronal axons. Hey, Byung-hun. I hope I said your name right. How are you? What am I doing? I'm reviewing vet school material. So right now I'm going over physiology and histology. Gray matter contains neuronal cell bodies and dendrites. Number 5, in the CNS, which type of glial cell synthesizes and maintains the myelin sheath, often myelinating multiple axons? In the CNS, it is D, oligodendrocytes. Question 6, what critical function do astrocytes perform that establishes the basis of the blood-brain barrier? It's not A, that is microglia. Could be B, I don't know. Could be C. I think it's C. Nope, it's B. Substance movement regulation. Okay, question 7. What are the primary input structures where signals typically enter a neuron? I think it is C. Yes, dendrites or occasionally the cell body. Question 8. Which morphological type of neuron is the most common in the PNS and the CNS of vertebrates, possessing many processes? or processes. Most common, I'd say, is the unipolar or bipolar. Okay, multipolar. All right. Well, okay, I should have known when it says possesses many processes. Question 9. What is the approximate voltage value for the resting membrane potential of a neuron? And which specific ion leak is primarily responsible for the continuous drift in the RMP, resting membrane potential? I think it was -55. Sodium leak. Or -70 is a potassium leak. I don't know. Okay, it was B, -70, and a potassium leak. Now, I've heard of potassium leak before. Potassium leak channel, so that makes sense. Question 10. An action potential is guaranteed to occur if the membrane voltage reaches the threshold potential. What is the approximate threshold potential value? Can't speak today. Well, I think it was a positive number, so I think it's +30. Nope, -55. Okay. Question 11. Which specific ion channel is primarily responsible for the rapid depolarization phase of the action potential? Voltage-gated sodium channels. Question 12. The absolute refractory period occurs because the sodium channels are in which state? A, hyperpolarized, B, resting, C, inactive conformation, or D, open conformation. I think it's B. Nope, it's C. Inactive conformation. Question 13. In myelinated neurons, the action potential impulse is recharged and propagated by saltatory conduction at which specific anatomic location? Nodes of Ranvier. Question 14. The increase of which ion concentration in the presynaptic terminal triggers the fusion of vesicles containing neurotransmitters? Calcium ions. Okay, I was going to guess that, but I'd rather not have to guess. I'd rather just know. Question 15. What protein complex is activated by calcium influx and is necessary for the neurotransmitter vesicles to fuse with the presynaptic membrane during exocytosis? Well, I think it's kind of given right here. Yep, snare complex. Question 16. If a stimulus causes the voltage membrane to change from -60 millivolts to -90 millivolts, moving further away from the threshold potential, what type of response is this? I think B. No, because it's making it more polarized. So maybe it's C. Yes, C. Question 17. Where must sufficient membrane depolarization through the summation of inputs occur to initiate a self-propagating action potential?
I don't know.
C, I guess? Yeah, C. Question 18. Which class of postsynaptic receptor facilitates very fast signaling by opening an ion channel directly in the center of its structure when bound by a neurotransmitter? A. Metabotropic. B. G protein coupled. C. Ionotropic. Or D. Special sense receptor. I think it's either A or C. Probably C. Yep. Because calcium. That's just what I thought of. Question 19. Monoamines, small molecules like acetylcholine, amino acids, and peptides are examples of what chemical messenger are used to transfer information at the synapse? Neurotransmitters. Easy peasy. Question 20. What is the primary enzymatic mechanism used to terminate the signal of acetylcholine at the synapse? I think reuptake. It's either that or degradation. I think it was degradation. Well, metabolism makes sense too now. Probably degradation, because I think only about 5 to 10% was reuptake. Or maybe it's diffusion. I don't know. It was degradation. Okay. Man. Glutamate and GABA are classified as the primary brain neurotransmitters. What are their respective functions, excitatory or inhibitory? GABA is inhibitory, glutamate is excitatory. So D, yes. Question 22, meninges. Which of the three layers of the meninges is the inner thin layer that is directly adhered to the surface of the brain? Pia mater. Question 23. Cerebrospinal fluid is produced by modified ependymal cells outlining the choroid plexus. Which space is the final location listed for CSF transport and resorption? The brain, no. The subarachnoid space. Question 24. Which non-neural glial cells in the peripheral nervous system surround the neurons located in sensory and autonomic ganglia? Non-neural, so it's not A or B. I think it's C. Oh, it's D. Question 25. In the lower motor neuron system, the axons terminate at what critical junction? The neuromuscular junction, I guess. Yep, that makes sense. Okay, that's all the questions. I would go over the review stuff, but I don't really have time. So I'm going to have to end the stream here and go to class. But thank you everybody for watching. Appreciate all you viewers, and thanks again for watching. I'll see you in the next one.